Okay, so let's start our next session. We'll receive Michael Bright, who will talk to us about Unikernels in action.
No, wait for the end. You don't know if it's worth it yet. Okay, thank you. So, yeah, I'd like to talk about Unikernels. So, I'm Michael Bright. I work for Contentious, a small startup in Lyon who make traffic. Okay, so I want to first of all talk about what are Unikernels. I don't know if people have a good idea. We're not talking about operating systems. We're talking about really minified images of applications. I'll go into that into detail. So look at what they are, what they aren't. Their advantages, their characteristics, the application domains in which they could be used. I mean, they're not something that are general purpose. Okay. And I'll look very quickly at the different implementations. There are easily about 10 to 20 different projects for Unikernels today. And then I will focus on just one of them, which is IncludeOS. It's actually a Norwegian company who've done an open source C++ based Unikernel. And I'll talk a little bit about what I expect to see in 2018. Okay. So what are Unikernels? There's a good definition. Specialized single address space machine images constructed by using library operating systems. So what does that mean? Well, specialized, first of all, is really special to one application. We're not building an OS on which you'll run one or two applications. We're building an application which is itself a machine image, which would normally run on a hypervisor as a VM. Possibly on bare metal, but not so often. And it says constructed by using library operating systems. So in fact, there is no operating system, but you just take the components of an operating system which you might need, which means if you want networking, which is usually the case, then you include a networking stack. If you don't need it, you don't. Same with the file system. Same with the floppy driver. Who wants a floppy driver? But it's in most OSs, even in Amazon Cloud Images. Okay, I love this quote from one of the guys of IncludeOS. VMs aren't heavy, virtual machines aren't heavy, OSs are. So if you can run Unikernels in, they'll be a lot lighter. So just pictorially, this is what a typical application looks like, the whole stack from hardware. Maybe it's running in a hypervisor, maybe even be running in a container. Above the kernel, you have users processes, parallel threads, language runtime, application binary, and library files and configuration files. That's quite a heavy stack already. And in actual fact, for a given application, do you need all those things? Because in there, when I say kernel, there's obviously hundreds of device drivers as well, which your application is maybe using, let's say 10 device drivers. Yeah? You don't hear me so well?
It's working. Maybe I should put a little bit up.
Okay. Is that better? Yeah? Okay. I'll try to shout. Okay. On the other hand, the Unikernel application, this is what you'll be running. You will have really just one binary image, which is going to contain the Unikernel runtime itself, your application code, and any configuration. Configuration, that means if it's a DNS server, for example, you're actually going to have a whole data of your DNS server in there, which can be an advantage. Might sound strange, but it means that your whole DNS server is now immutable. You want to make changes, you actually deploy a new Unikernel. What it's not a general purpose OS, and it's not a minified general purpose OS. So we're seeing a lot of these like Project Atomic, CoreOS, CoreOS Linux, Linux Kit. Do a great job, but these are still minified, coming from a general purpose OS and minifying it. Unikernels are really a bottom-up approach. So basically, they're very small compared to an application running on a general purpose OS, even a minified one. Uses very few resources, which means potentially as virtual machines, you can have very high density. If the hypervisor can handle it, you can have thousands of these VMs running at once. They should be very fast to start up. But I have a slide that mentions that. There's no separate kernel space, usually. So normally when you're writing an application, your application is running in user space, and any file system access, there's a context switch to get into kernel space. Unikernels don't have that. Everything is in kernel space, which isn't a problem because there are no users to protect yourself from. This is a single user system, a single process system. They're supposed to be more secure because they have a smaller attack surface. They obviously have a lot less code as you're only selecting the parts of the OS that you actually need. There's no shell, by the way, which kind of makes debugging a bit trickier. On the other hand, if a Unikernel gets optimized, compromised, there's not a lot that someone's going to be able to do with it. There's no shell, there's no processes, there's just one thing that is happening. And as I mentioned, they're very fast to boot and can be a good way to getting on-demand services. On the other hand, they will be more difficult to develop because you don't have all this Linux environment. So typically, you might want to develop your Unikernels building for Linux and debugging, more sort of application-level debugging, and then building as a Unikernel to do your final debugging and deployment. In terms of application domains, so these aren't general purpose. It could come as tools become more sophisticated, but they are more difficult to develop and debug today. One area is cloud computing and NFV in particular, particularly cloud for telcos, where high network throughput, high security, and fast startup is of interest. IoT and embedded is another domain which could be useful for them. High performance computing, less, but you can certainly get better performance out of these things than standard OS. But you have to sweat to get there. Okay, I'm going to go through these slides very quickly. It's really just to point out there was an IETF draft that was done just comparing standard OS, VMs, containers, and so on, comparing those technologies. And I really just wanted to point out that in some cases we can see the Unikernels really come out ahead. So the time to create a new Unikernel is easily 10 times less than the other technologies. 31 milliseconds in the case of Zen, which is pretty impressive. Similarly, for throughput, they're up there at about 50 gigabits per second. Round trip time, again, pretty low. Only container is actually better in this case. Why would containers be good as well? It's because you don't have a VM, so you don't need to use things like SRIOV to get around the kernel. Image size, very small. In the case they used, it was a 2 megabyte image. Memory usage, very low. Containers actually a little bit better, which is normal because container runs over a host OS, whereas a Unikernel has to include as well some elements of OS capability. Okay, so I want to look quickly at some different implementations. I want to get very quickly to a demo. So just to be clear again, we're really talking about building your application with the minimum components that's necessary. I hesitate to say minimum components of an OS because it isn't an OS, but it's really the idea of a library OS, just taking the stacks that you need and nothing else. Okay, so it is not running on Linux at all, but it will be running on a hypervisor. There are two families of Unikernels, what we call clean slate, which is really this minimalist bottom-up approach, where anything you would need from an OS, you actually, well, has to have been re-implemented. So one of these Unikernel families would have already created a set of libraries with these capabilities. They typically use type-safe languages, I'll see in a moment. Very small code size, few resources, but it is harder to develop apps. There's also a class called legacy, where basically it's not quite as purist, and they aim for things like POSIX compatibility, which is already bits of legacy. Has advantages, will make it easier to develop applications, but you're moving away from the pure Unikernel idea. Reusing existing libraries and having binary compatibility. So personally, I think it's really the clean slate approaches which are of more interest. Okay. So in terms of those families, if I just look at the legacy ones, there's quite a few already. That didn't work very well. This one, RumpRun, for example, and there's also LPL, which is basically a modularized form of the Linux kernel. So already, if I'm talking about modularized Linux, you can tell it's not quite the same building things from the ground up. That's really the approach of the legacy systems. There's always this trade-off between the ease of development and performance, security, efficiency that we'll see with the clean slate. On the other hand, until now, most of the clean slate unikernels have been in languages like OCaml, Haskell, Erlang. So these are fairly esoteric languages which are not what most people will want to be developing in. There is another alternative, which is this IncludeOS, which I mentioned, which is entirely written in C++. And in the future, maybe they'll be able to include other language interpreters. There's also a set of tools. Solo 5 is what we call a unikernel base. Basically, we say these unikernels start from scratch, but they try to have some sort of base of libraries that are available to the different projects. Solo 5 is one that came from IBM, and they also did this thing, UKVM, which is actually the same way that unikernels are a library OS. UKVM is a library hypervisor, so it takes functionalities of the KVM that it needs for your application. Okay, so it's a very lightweight KVM. Unique is a project, came from EMC Dell originally, for compiling across different Unikernel projects because there's a lot of commonality. And a new project by NEC Unicraft, part of the Zen project, which is basically they're wanting to build a simple interface where you can select from a menu, okay, I want to target this platform type, and I say x86 running on Zen or KVM and so on, and then which library OS features I want. Okay, but I want to talk about IncludeOS, and in particular get to a demo. So as I mentioned, okay, it's all in C++, and it's kind of nice, the idea that you would have a hash include OS, which makes your application become a unikernel. Okay, it's not that simple. It runs on quite a few hypervisors, so KVM, VMware, ESXi, on VirtualBox. And they've recently added E1000 NIC support, which means that they should be able to run on some bare metal. That's usually the thing that you want to avoid with unikernels, because as soon as you start adding hardware-specific drivers, you just get into a real messy situation. But if they focus on one or two networking cards, anyway, you pull them in as a library as needed, then they should be able to run on bare metal. They're currently looking to integrate Musel libc, which should give them a leg up. So Musel is a very minimal libc. They've defined a DSL, NACL, which allows to specify network characteristics. It looks roughly like this. You can define your interfaces, you can define routes and stuff, and so it can be just a help for creating network components, which is one of the main target applications that will be used for Unikernels. Okay, I want to move very quickly to get to a demo. What I'd like to show you, I basically just got a web server application coming from IncludeOS, written in C++. And I hit return. Okay. So it's basically just building that application, and it will automatically start the Unikernel locally, I think directly under QEMU. Okay. And that's just to show that we can have a local binary running. I'm going to hit Control-C to interrupt that because we're not interested in that. And then I will load that image up into an OpenStack platform. Okay, so we just see it doing a set of OpenStack operations. And below, I just have a watch, which is just showing us images and servers start to appear on the OpenStack platform. Okay, so it created a new image for this IncludeOS Acorn web server. It's now just started the server, and it's waiting for that to come up. It's come up, and I need to open an SSH tunnel because the system is in Geneva. Okay, so I needed to know that. Try again. I needed to know the IP address of the VM in OpenStack before I can open the tunnel. Okay. I didn't show you. Well, just believe me because we don't have much time. Okay. The image size of that application is, I think, about 4 megabytes. Actually, we'll see it here. So this is the web application. It's actually 4 megabytes or so. It's all written in C++. It has a dashboard, which we'll see, a REST server, and also serves up static files, as a web server usually does. If I go to the dashboard here, okay. See, that's fairly interactive thing. We can see statistics about the usage of memory by the Unikernel. 1.5 megabytes of heap. Down here somewhere, hold on that. Somewhere we see the actual size of the executable. Oh, here it is, yeah, ELF. Your service binary, 3.8 megabytes. That's pretty small for such a small web server with a fairly complete dashboard. There's, as I mentioned, there's a REST interface, and I can also just traverse that interface. Okay. So I just wanted to get very quickly to show a real working example of Unikernel. So that's where I got to. So I didn't really show you the steps, but it was very simple to actually build the Unikernel, in case you thought it was quick. I deployed that onto OpenStack. I mean, actually first ran it on QEMU, and then on KVM on OpenStack. In the past, in other conferences, I've done other demos. There's a site called deferpanic.net, where you can build some example Unikernels online. And in one conference, this presentation, which is Remark.js, I just included that in a Unikernel. It's very quick to include, and then displayed my presentation at the conference in a running Unikernel on their site. Runtime.js I showed, which is basically V8 JavaScript engine running as a Unikernel. Unfortunately, that's a project that actually stopped a few months ago. MirageOS, so this is the one. Basically, a lot of MirageOS employees were brought into Docker when they bought Unikernel systems. So I did a demo of, so I had an OCaml DNS server application, just one of their examples. I built it for Linux, ran it locally. I built it for UKVM and ran it under that hypervisor. And then I loaded it up to Google Compute Engine and ran it there, made requests. Google Compute Engine, well, all the standard cloud service providers are the worst place to run a Unikernel today. Just an example, Google Compute Engine, and using the dashboard, the minimum disk size I could have was 1 gigabyte. If I used the CLI, minimum of 10 gigabytes, which is just crazy for Unikernel. So I don't do that anymore, because it was costing me money anyway. And another one was this project OSV, one of the legacy kernels, seem to be advancing quite well. They have things like Tomcat, a whole load of applications that will build on their POSIX-compatible system. Okay, I'm out of time. Just to say in 2018, so 2017, not at this conference, but a week later in Grenoble, I presented, and I was saying, yeah, I'm sure Docker are going to announce some great things and Unikernels this year. Well, they didn't. But they did announce Linux Kit, which has nothing to do with the Unikernels, but still is that same mindset. Who knows, in 2018, I don't know. I don't know if Docker will, but the MirageOS project continues to trundle along. And all these Unikernel projects, I see them making strong progress. Solo 5, as I mentioned, this Unikernel base with the UKVM seems to be adding more and more back-end support, which is interesting. IncludeOS, they did get one trial deployment last year. I'm sure they will get more deployments. They seem to be advancing very rapidly in their capabilities. Okay, I'm going to stop there because I'm out of time. Are there any questions? Stunned.
One question. So, if you were to recommend a quick way to test Unikernels, what would it be?
Quick way to test them? Okay, so what would be a quick way to test Unikernels? If you really just wanted to try any Unikernel quickly, I'd say go to the deferpanic.net website, where you can just try things, all in a web browser. So that's quite nice. Otherwise, real hands-on with stuff, you just have to go to the GitHub of the respective projects. I can't think of any one which is easier than the others to get going. Last question, I'm being told.
So what about, so you were talking about the compatibility with the application and the development model for the application. What about the hardware management side of things,
Yep.
drivers, etc.?
So normally, the main use case for Unikernels is to run above a hypervisor. So there's a limited set of drivers to be compatible with the appropriate hypervisor. Okay, but it is possible as well to run some on bare metal. Generally, it's not that well tested, and it will be a lot of work.
If that's the case, are you going for VirtIO style drivers, or you mentioned E1000 at one point?
Yeah, so I know IncludeOS are doing VirtIO style drivers, yeah. But it's, generally speaking, there's another advantage of running within hypervisors. It's the fact that you can really have potentially thousands of these things running at once, and being assigned to cores appropriately by the hypervisor. So bare metal is a corner case, I'd say. Okay. Thank you.
Muties.